So for this problem, we want to find the general solution for dv by du is equal to v plus 1 over u plus 2, giving your answer in the form v equals some function in terms of u. So we've got another differential equation here, which means we need to isolate the variables. In this case, we need to isolate our u variable and isolate our v variable, and we want the dv and the du up in the numerator so that we can then subsequently integrate. So if we move the du over, and if we move this v plus 1 down into the denominator on the left hand side, so we've got 1 over v plus 1 is equal to 1 over u plus 2 du. And at that point we've actually isolated the variables. It's quite a nice one to isolate. A little bit more work is going to be involved in our next stages. So like with the last problems, we're going to need to integrate both of these. And we've got 1 over a linear factor, so when we integrate those, we're going to be making a natural logarithm appear. And both of these are quite nice expressions. The natural logarithm of v plus 1 is equal to the natural logarithm of u plus 2. And we can't forget, both of these will generate a constant of integration, so if we bring them both to one side, we're going to get a plus c there. Now, the problem is we want this in the form v is equal to some function in terms of u, and we've got two natural logarithms. Well, we don't like this plus c in this form, so we're going to rewrite c as ln k, where k is a constant, and that's going to make things much easier for us to deal with. So we've got ln of v plus 1 is equal to ln of u plus 2 plus ln of k. Well, we can combine these two logarithms together. If it's a plus, it means those two parts are going to multiply. So you've got ln of v plus 1 is equal to ln of k times u plus 2. And we can get rid of the logarithms because you can take exponentials of both sides. So we're left with v plus 1 is equal to k times u plus 2. And then the very final thing we need to do, move this plus 1. So v is k times u plus 2 minus 1, where k is just a constant. And then we've got it in the form v equals f of u. So therefore we have finished our problem.